Hey guys, welcome to the video where today I'll be talking about atomic structure. And if you guys haven't already, go ahead and check out all the previous videos that I have on the channel, as well as the previous video where I do talk about some of the essential chemicals to life. Okay, so without further ado, let's get right into it. Here I do have a small chart here going over a recap of last video. And I want to talk about matter. Matter is anything that takes up space. And if we bring out our good friend here, Tyrion Lannister, I showed him on the last, his debut in the last video. We can see that this guy here is made up of matter, right? And matter, again, is anything that takes up space. Or even this whale lord that we have, a cool Pokemon that I really love, right? This big whale. He takes up space. Again, matter is anything that takes up space, even if it's this small ant or whatever, right? On Pence's head. Well, actually it was a fly, but you guys get the point. Anything that takes up space is matter. And if we go even deeper, right, we have something called elements. Elements are they cannot be broken down further by any chemical reaction. And we see examples in the last video like carbon, oxygen, hydrogen, nitrogen, or sulfur, just to name a few. These are all elements and they cannot be broken down any further by chemical reactions. After this, we have atoms, right? And these are the smallest units of matter, right? In the last video, we saw helium, the helium atom, right? And in this atom, we had something called subatomic particles. So as seen here, subatomic particles. Some of those examples are proteins. I made so many protein videos. I almost slipped up and said protein. Protons, neutrons, and electrons, right? These are all subatomic particles that make up atoms, right? So let's dive right into it. So what we have here again is protons, neutrons, and electrons. We can see the protons are highlighted in purple and they make up the nucleus of the atom, right? And then to our left, we have the electron, which can be found in the electron cloud on the outer part of the atom, right? And let's talk about some of the charges. So for the proton, we have P, proton, for positive. So these are positively charged, right? Then we have neutron, or neutral, no charge, right? So there is no charge with the neutron, right? Neutral. Then we have the electron, right? This is negatively charged, right? And also another thing we see is how the proton and neutron are in the center. And this is called the nucleus, right? And then if we look to our bottom left, we have this purple square or rectangle, and it says almost identical in mass, grams, 1.7 times 10 to the negative 24. What does this mean? This represents the proton and the neutron, right? The proton and the neutron are almost equal in size. You can even see it in the photo. They equal about 1.7 times 10 to the negative 4th grams. They are very, very, very small, but they make up a large amount of the mass of an atom, right? And if we look into 1.7 times 10 to the negative 24th, again, that's very small. It's written in scientific notation, and I won't write out all the zeros, but to give you guys an idea, think of this is how small it is, and it just continues on until we hit the 17 at the end. It is that small that it has to be expressed in scientific notation, right? And also, we have a guy to our right. His name is John Dalton. He coined the term Daltons. This is how we measure the subatomic particles in Daltons, right? Yes, this is how we, again, measure the atoms in Daltons. It's very, very small. Again, this was by John Dalton in the 1800s. He was a British scientist. He also developed the atomic theory. So let's go ahead and give him a round of applause. Woo, John Dalton, woo, right? And now if we look to our bottom, we have the blue rectangle here saying very small. And that represents the electron. The electron's mass is so small that it's very insignificant comparing it to the proton and neutron. Again, the proton and neutron are very small, but still they make up the larger percent of that atom's mass. As to the electron, it's so small that it is very insignificant. It's so small, right? So it doesn't really add any of the mass to the atom, right? So now if we move on to our right, we can go more into atomic number, atomic mass, and more things of that nature. And we know that every element, it differs in their subatomic particles, right? So let's see what that means. So first, let me go ahead and identify these. So we have here the atomic number, right, at the top. And what does the atomic number tell us? So the atomic number, which I'm going to write as AN, gives you the number of electrons. Let me go ahead and erase something real quick. So the atomic number gives you the number of electrons, and it gives you the number of protons, right? That is in an atom. Then in the middle we have the element symbol, which again can be carbon, hydrogen, oxygen, whatever the case may be. And then to our bottom we have the atomic number, which I'm gonna write out as AM, right? And AM again is the atomic mass, okay? So what I want to do is kind of blow up this periodic table so we can get in a good example. It's kind of blurry, but I think it should work, you know. I always get conscious about saying blowing up, because I mean we don't want anything to blow up, but I'm blowing up this image so we can get a better idea, right? So I'm going to take oxygen. Can you guys point out what the atomic number is for me? I'll just give you guys a second. Perfect. The atomic number would be 8, right? Right at the top. And what would be the atomic mass? Perfect. The atomic mass would be 16. So another thing I want to point out about the atomic number and atomic mass is that if you guys notice, the atomic mass is usually larger than the atomic number, right? So this is a good way to identify what is the atomic mass versus the atomic number. So again, the atomic number is 16, the larger number. If we even look at, let's say, chlorine, what's the atomic number? 17. The atomic mass is 35. The larger number is always, in this case, the larger number. Even without knowing, let's just blindly go into something, right? Let's just hit up carbon, right? What's the atomic mass? 12. It's the larger number, right? So now we identified the atomic number and the atomic mass. Now, how much protons and electrons does oxygen have? Remember, we said that the atomic number gives us the protons and electrons. So the number of protons and electrons in oxygen are 8. And we have to remember that there is a balance between the electrons and protons. So the number of protons will equal the number of electrons. So if there's 8 electrons, there will be 8 protons. If there's 2 electrons, there will be 2 protons. There must be a balance there. They will equal. So now we're going to ask ourselves, okay, we have the electrons and protons. How do we find the amount of neutrons, right? So I'm going to build this equation here. This is how we find the number of neutrons. So what we'll do is we take the atomic mass, which is AM, and then we subtract the atomic number. And then we will get the number of neutrons, right? So if we blow up once again to our oxygen, we know that, again, we have 8 electrons and 8 protons. To find the number of neutrons, we are going to take the atomic mass, right? And we will subtract that from the atomic number. So essentially what we have here is, what is the atomic mass? 16, right? minus the atomic number, which is 8. And then we are going to get 8. So oxygen has 8 protons and electrons. Oops, that didn't come out right. 8 protons plus 8 electrons. And now the number of neutrons is also 8. So 8 neutrons. So 8 protons, 8 electrons, and 8 neutrons. All right. So let's blow this back out. And let's go over here to an example that we have down here with lithium. And why I put these two examples is because I want to show how sometimes chemists, they get a little bougie and they write things, a different way. So these are two different ways that you may see an element be written out, where some of the numbers are to the side, one is at the top, one is at the bottom, and so on and so forth, right? But you guys are smart enough. I have all the confidence in the world. So let's go ahead and take this lithium, for example, right? The one to our left. So how do we start off? Let's identify the atomic number, right? The atomic number is 3. So how many electrons and protons there are? Let's look right up here. We know that the number of electrons and protons are going to equal. So the number of electrons is going to be 3. And we know that the number of protons will equal 3 as well. Now to find the number of neutrons, remember, it's usually the largest number, right? We have 6.941, which is the largest number. That is the atomic mass. And for this sake, we round the number up. So instead of 6.941, it will just be 7, right? So we're going to have 7. And if we refer to our equation here, atomic mass, well, that's not the equation, but the atomic mass minus the atomic number, which is what? 3, we will get 4, right? So now we know that the number of neutrons equals 4, okay? Now, if we look at this example here to our right, it is the same thing. The only difference here is the numbers are just in different places. But again, we're smart enough, right? What is the atomic number, right? The atomic number is 3. And what would be the atomic mass? The larger number, 7. So again, we can see here where we do have 3 electrons and 3 protons. And the atomic mass would be 7, the larger number. And then if we want the number of neutrons, we would just do 7 minus 3, and that gives us 4. Okay, so I hope this video really helped you guys kind of go over atomic structure, and as far as finding the number of electrons, protons, and neutrons, as well as some, little shakes in the rug that we have here where they give you, different examples of writing the elements and having the numbers placed in different places. I highly advise you guys watch this video a couple times, so you guys can get familiar with atomic number, atomic mass, and some of the terminology, as well as finding the amount of neutrons. I also recommend watching the last video just for more of an overall basis of some elements, substances, and other things that I find very important. So if you guys haven't already, go ahead, leave a like, comment, subscribe, ask any questions that you guys have, and thank you for stopping by, and I'll see you guys next video. Peace.